Hello everyone, we will be solving two problems from series and parallel AC circuits, and we will be dealing with inductive reactance. These are the problems. In one problem we have to find the equation of I, and another problem we have to find the equation of V. In the first problem we can see the voltage is given 24 sine omega t and the XL is given 3 ohm. The XL is called reactances. If L is given, we have to find reactance first, then we will convert that to impedance. As we know, the inductor introduced 90-degree shift in current waveform with voltage. So the impedance equation is ZL XL angle 90 degree. This is the equation of finding reactances. XL is equal to omega L is equal to 2 pi FL. Now look into the solution. Our ZL is equal to XL angle 90 degree equal to 3 angle 90 degree. Now we have to convert the equation of V to phasor form. So small v is equal to 24 sine omega t. In phasor form it is 24 angle 0 degree. So I is equal to V divided by ZL. So I is small, V is small. So V is equal to 24 angle 0 degree and ZL is equal to 3 angle 90 degrees. Now divide these two using a calculator. Before starting, we need to convert the mode to complex. This is a must. So we will put the values 24 angle 0 degree divided by 3 angle 90 degree. That gives us minus 8i. So we need to convert these to polar form. That is our answer. 8 angle minus 90 degree. So if we convert that into instantaneous equation, it becomes 8 sine omega t minus 90. Now look at the waveforms of V and I. This is V, the black line. The peak value is 24 volt, and since the waveform equation was V is equal to 24 sine omega t, so it will start from 0. And the blue line is our I. The peak value is 8 ampere. Since it has a minus 90 degree, so it will start from 90 degree. So here current is lagging the voltage. This is the phasor diagram drawn with peak value. Since the voltage do not have any angle, so this is 0 degree. Since the current is minus 90, so this is minus 90. And our voltage is leading the current. And the value is 24 volt and 8 ampere. If we draw these using RMS value, this is our phasor diagram. Here everything is same except the value. The value is 16.968 and for current it is 5.656. How we got that? We divide the peak value by √2. Now solve the second problem. Here I is given 5 sine omega t plus 30. We need to convert that to phasor form. Before that we will find the ZL. ZL is equal to XL angle 90. So XL is 4 and that is 90. Now I is 5 sine omega t plus 30. So it is 5 angle 30. Now as we know, V is equal to IZL. So I is 5 angle 30 and ZL is 4 angle 90. Let's calculate these using calculator. Before calculating, we need to convert the mode to complex. We'll put the value 5 angle 30 into 4 angle 90. that gives us minus 10 plus 10 root 3i. We need to convert that to polar form. So 20 angle 120. That is our answer. If you convert that into instantaneous equation, that is our equation. Small v is equal to 20 sine omega t plus 120. Now, see the waveforms of v and I. The blue waveform is the waveform for v, and the peak value is 20 volt. And the black waveform is for I. The peak value is 5 ampere. Since the equation for v was 20 sine omega t plus 120, so it will start 120 degree ahead of our 0 point. And since the current equation was 5 sine omega t plus 30, so it will start 30 degree ahead of our 0 point. So our voltage is leading the current by 90 degree. Now let's see the phasor diagram. This phasor diagram is drawn with peak value. Here the voltage is at 120 degree and current is at 30 degree. So in between them they have 90 degree shift and the voltage is leading. The peak value of voltage is 20 volt and the peak value of current is 5 ampere. See, this is small v, this is small I. So if we draw this phasor diagram with RMS value, this is our phasor diagram. Everything is same except the values. This value we got by dividing the peak value by root 2. This one and this one. And this is capital V because it is RMS. This is capital I because this is RMS. That's all for today. See you in the next video.